Hello everyone. Today we're going to be looking at a system of linear equations and approaching them graphically and seeing what that means. So our objectives are going to be to first define what a system of equations is, then see how we can identify solutions, and last we'll place a graphical interpretation of a solution. So the definition of a system of equations. A system of equations is a set of two or more equations in two or more variables for which a common solution is sought. So for example, x plus y equals 5 and 3x minus 3y equals 9 is a system of equations because we're trying to simultaneously solve those two linear equations. Find an x and y that works for both of them. So one preliminary example is to identify a solution. So for example, is x comma y equaling 6, negative 1 a solution to our system of equations? For it to be a solution, it must be true in both equations. So if we take the first equation and we plug in x to be 6 and y to be negative 1, then you could see that 6 plus negative 1 does equal 5, so it does make the first equation true. Now when we go to see about the second equation, and we plug in x to be 6, and we plug in y to be negative 1, and we ask ourselves, does that actually equal 9? We could see that it doesn't. It turns out to be 18 plus 3, which is 21, but that doesn't really matter. What matters is that it doesn't equal 9. So is 6, negative 1 a solution? No. 6, negative 1 is not a solution. It does make the first equation true, but not the second. So what is a solution? Well, let's show that 4, 1 is a solution to our system of equations. Again, we'll verify by plugging in 4 and 1 into both into the first equation and our second equation. So we can clearly see for the first equation, plugging in 4 for x and 1 for y, that 4 plus 1 does in fact equal 5. And for the second equation, we'll plug in x to be 4, just like we did on the last one. We'll plug in y to be 1. And again, we're going to ask ourselves, does it equal 9 this time? And if you look, 3 times 4 is 12. And 12 minus 3 does equal 9. So since it made both equations true, we have shown that it is in fact a solution because both equations are true for our value of 4, 1. So we've identified that 4, 1 is a solution. Let's see if we can interpret that solution appropriately on a graph. So finally, let's graph our system and identify the solution graphically. So in order to do that, we'll bring in a grid here so that the lines are at least semi-straight. The first line, x plus y, x plus y equals 5, I'm actually going to graph using the intercepts because it's pretty easy to see if you plug in x to be 0 that y should be 5 because 0 plus 5 is 5. And similarly, if you plug in y to be 0, x should be 5. So that immediately gives me two ordered pairs, so I can graph my line. So let me draw on the axes here. So there's the x-axis, there's the y-axis. Draw on some tick marks. There's 5. I'll draw on a few more tick marks. There's 5 again. And so my first line has a y-intercept of 0, 5 and an x-intercept of 5, 0. and I connect those two, I get the line x plus y equals 5. For the second line, I could actually do the same thing because notice all the coefficients are divisible by 3. But instead, I'm going to put that in y equals mx plus b form. So I'll move the 3x over to the other side, left with minus 3y equals negative 3x plus 9. And then I'll divide everybody by negative 3. When I do that, negative 3 divided by negative 3 is 1x. And 9 divided by negative 3 is minus 3. So to graph this line, I'll use the slope, which is 1, or 1 over 1, to use rise over run, and I'll use the y-intercept, which is 0, negative 3. And so I'll start at the point 0, negative 3, and I'll go up 1 and over 1, up 1 and over 1, up 1 and over 1, and I can keep doing this. And notice that when I do that, I know I came up with more points than I needed, but look at that. Right here is the ordered pair 4, 1, which happened to be our solution. So when we think about that, that makes sense because a point of intersection of these two lines is going to be a point that is on both lines and thus satisfies both equations, hence our solution. So that concludes our video about systems of linear equations, taking a graphical look where we define what a system was and we learned how to identify if something was or isn't a solution. And last but not least, how to graphically interpret the solution as the intersection of our two lines. Thank you and have a wonderful rest of your day.